Hi guys, so today we are going to talk about logical volumes. This is like the 50th time I've tried to make this video, so hopefully this works out. Yeah, I keep recording the wrong screen and like the audio doesn't work and there's all kinds of weirdness going on, so it's been a challenge. Anyway, let's try to move through this as quickly as we can and hopefully this time it will work out well. So basically logical volumes are sort of like a layer of abstraction between your physical disk and your your like partition scheme. So normally you'd have like an SDA volume, and then you have SDA1, SDA2, SDA3, which is true of this one if we do LSBLK. LSBLK. You can see we've got SDA here, SDA1, SDA2, and SDA5. These are LSBLK is kind of a little tool that lets you look at your partition layout. List block, I think, is what it stands for. Yeah, it's just a neat way to look at your disks, along with df tac h, fdisk, and other commands that we have talked about probably in prior videos. So LSBLK is a nice tool that we're going to be using a lot in this video. Anyway, so this is the normal partition structure of a disk. So logical volumes, you can use a partition, that's perfectly fine, and most of the time if you set one up from scratch, like if you install Debian and then do and then set up logical volumes, you'll see that we in fact get that set up where one of the partitions is your logical volume and it just joins that up. But that's not really the best way to do it if you're adding multiple disks, like a second disk, like SDB in this case, right? So if you're adding a secondary volume, you're going to want to just set that disk up and then just have it be a raw disk with LVM on top of it. And the reason you're going to do that is it leads to the disk being a lot more flexible. You can grow things easier, you can shrink things easier, you can move stuff around easier, you can provision it, resize it, whatever, and you can do it dynamically inline without rebooting and having problems, etc. and so forth. It's also best if the SDA volume is not a part of that, because SDA is trickier to resize without having to reboot, because it's your boot volume and roots on it and stuff, right? So that's why it's a good idea to keep root apart from the rest of your storage. Anyway, so SDB is here, and it is in fact a virtual disk, and it's 10 gigs. So now I'm going to teach you guys how to actually create a logical volume, and a volume group and logical volumes. So let's discuss what a volume group is. So basically a volume group is a group of volumes, which seems pretty obvious, right? It's self-explanatory. But what does that really mean, right? So it doesn't become very apparent with only one volume as I have here, right, with SDB, because SDA is not going to be a part of our volume groups. That's already provisioned as for the operating system. SDB is the only thing that's going to be in this. So the benefits of having a volume group become more apparent when you have more volumes, right? Because you can actually pool them together. So if I had SDB and SDC and they were both 10 gigs, then I could basically create almost like a RAID, where now it isn't a RAID. There is something called MATM for that, and that's beyond the scope of this video. But you can do sort of a pseudo RAID-ish sort of deal where you can take two disks and sort of weld them together into one giant storage pool. And that's basically what a volume group is. You can think of it as a storage pool. And then you have logical volumes, which sit on top of your volume groups, and those are like provisioned sections of your storage pool. So think of a volume group as a bunch of disks welded into one pool, and then think of your volume groups as your individual partitions. Or not your volume groups, sorry, your logical volumes are your individual partitions, and in fact they will be mounted as if they are individual partitions. So you can see in here I've actually got this file or this folder already made called demo. This is the mount point where we're going to be mounting our logical volume. So if I do ls, actually let's just do, well, pwd, I mean I'm in /mount, right? So cd /mount will get me here. And this is where you should probably create mount points if you're creating them, for like external mounts, like if you're mounting a remote file system on a foreign server somewhere, or if you're creating a mount point for something, put it in /mount. That's a good spot for it. /media is not for that. That's for like if you stick a USB thumb drive into the front of your computer, or you stick a CD-ROM in, God forbid you have one of those. But nowadays, if you want to use, like, if you want to make a drive or make something, a mount point for something, put it in /mount, MNT, that's what it's for. Anyway, so Here, what we're going to do is we're going to create a physical volume. So basically what we're going to do is we're going to provision a physical volume. So the first thing we got to do is we got to install Logical Volume Manager if we don't already have it. Now if you set up Debian or some other Linux system to be where its initial disk is Logical Volume Managed, you'll have it. If not, then you might not. So sudo apt install lvm2 is what you want to do as a Debian stretch, right? In my case, it's already there, so I don't have to worry about it. But in your case, maybe not. So if you keep getting command not found when you do the next set of commands here, that might be why. The other reason is you didn't say please. So if I do pv create, or actually let's just do pv display first. Always do a display first. It's just good habit, right? So pv display, if I do that, you'll see it'll say command not found. It's because I didn't say please. You know, if you do sudo, then it won't give you that error. Now notice also that it did not return anything. This is because no disks are currently provisioned, so there was no output. It's not going to give you any output if there's nothing to tell you, right? It's just going to return with no error. So if you get this, it's because you didn't say please, or you don't have your Logical Volume Tools LVM2 installed. So double check that, and then you should be good. So now we're going to do sudo pv create, and we'll do dev sdb, right? And this should create our first physical volume. So now SDB should be ready to be provisioned in a volume group and created and have logical volumes created on it. So if we do pv display now, let's just up arrow that, you'll see that it will return output. And you can see that I've created a volume, a physical volume has been initialized for use with volume groups, and it has 10 gigs of storage on it. So now what I want to do is I want to create a volume group. So let's do sudo vg display. I'm sensing a pattern here, right? So vg display, pv display, physical volume display, volume group display, and guess what? Logical volume display. LV display is a thing as well. So sudo vg display, okay? This will tell us about our volume groups. We don't have any yet, so we get no output. So let's do sudo vg create, and we're going to do vg1, and we're going to give it our target of dev sdb. This is going to create our first volume group. You can name that volume group whatever you want. vg1 is just a name, so it can be, you know, anything you want. It can be, you know, disk array, whatever you want to call it. Whatever seems logical to you. I'm just going to go with the generic stuff because this is just a demo. But anyway, so that's going to create our first volume group. So now if I do a VG display, you'll see that I have a volume group, and it has one disk in it. You can see current physical volume, one disk. And then you can see down here I've got 10 gigs of storage on the thing. I've got exactly 0 of that allocated, and I have 10 gigs free. So you can see that. I also have a VGUID. I've never seen a place where I needed to use that, but there it is. So those are sort of what you can utilize in order to understand your volume group a bit better. And then we can create our logical volume, right? So sudo lv create, okay? Or I'm sorry, let's do the display first. Got to keep good form here. Display. It's always good to know what you have before you go trying to manipulate stuff. It's very important when you're on a complex system that you check what's there before you start doing that, especially VG display, because a lot of times people say, hey, resize this logical volume to something else. And then if you just looked at your VG before you went growing things, you'd notice, hey, there's some free unallocated space that somebody left in this volume group that I could just use instead of having to, you know, add a disk. So it's important to look before you leap. Anyway, so sudo lv create to make a new volume. So I got to spell it right. create. There you go. And then what we're going to do is we're going to give it a capital L. Now there's a couple of ways we can do this. There's actually a little L and a capital L, and I'll explain the difference in a bit. But capital L is what we're going to start with, and we're going to give it 1 gig of space, right? 1 G. So, and then we're going to tell it we want to do VG1, because that's the volume group we're going to make it. We're going to give it a name, tack in, right? And the name we're going to go with is demo. Now I recommend, usually this is what I do, is I make the name of the volume group the name of the mount point that I'm going to use for the volume group. So you'll notice the file or the folder that I'm going to mount this to in mnt/mnt is demo. So that's why I'm using demo as the volume, the logical volume name. That way I can keep track of what the heck is what, right? So now if I press enter, I'll get this volume group. Now it's going to tell me there's an ext4 signature on it. It should not tell you that if it's a new disk, but if you've done something with this disk before, like I said, there have been more takes on this video, then it might give you this error. That's cool. It's perfectly fine as long as there's nothing on it and you know what you're doing. I'm not responsible for your data loss if you wipe something important, so just know what you're doing, okay? I'm going to go ahead and wipe it because I know this volume is not worth anything to me. All right, so now I have this volume. It should be provisioned, but it's still not tangible yet. We still can't do anything with it. We can't mount it yet, and we can't store anything on it yet. Why? Well, we've got the partition. We don't have a file system. We got to tell Linux how the heck we want it to store stuff. So, I personally, my preference is ext4. Why do I like ext4? It's more flexible than XFS. Now, there's a couple of others out there like ZFS and ButterFS. Those are beyond the scope of this video. ButterFS I had kind of a bad experience with. That's absolutely supported in Debian, but I had a bad experience with it in that I lost some data. So I don't know if it's really ready for prime time, or maybe it's just not up to snuff in Debian. I don't know, but and maybe other people do have good experiences with it. Personally, I stick with ext4 because ext4 has never failed me. XFS is great. I've used it a lot in RHEL, but the thing about XFS is it cannot shrink. It can only ever grow. So if you're in a situation where you're like, oh, I've over-provisioned a disk, it would be really nice if I could reduce that disk and move that available storage somewhere else where it might be better allocated. If you've provisioned that thing XFS, you're done. You can't shrink it. The only thing you can do is add a new disk, move your data over, destroy the partition, relay it out the way you want, grow it back up the way you want, right? Move all your data back over. With ext4, however, if your data is not overgrown the partition, of course, and you have available storage left on that drive, you can shrink an ext4 volume, making it a lot more flexible. However, it should be noted that if you are in a data center in which you know you've got a file system that's only ever going to grow, then yeah, XFS might not be a bad idea. XFS is pretty good at large file systems, like obscenely large file systems. But it should be noted that the benefits of XFS don't kick in until you get to, like, if you're still working with terabytes, ext4 is fine. That's how big we're talking, okay? So, realistically speaking, XFS has its value, but ext4 is more flexible, and I like flexibility, and I'm never going to be working, at least not anytime soon, with file systems outside of the terabytes ring. I'm not looking at exabytes, right? So unless you're in that situation, ext4 is my recommendation. However, if you're dead set on XFS, and that's very cool if you are, I respect that decision, my advice to you is incrementally grow that file system. Don't add like 40 terabytes to it. Add like 1 terabyte and then add another terabyte and just feed it incrementally, because once you commit that storage, you're kind of done. You stuck yourself in that situation and now you can't undo it. So definitely incrementally update it if you're going to do that. And that's fine if you are, but I would have gone ext4. So that's what I'm going to, now that I've given you my spiel on ext4 versus XFS, I'm going to go ahead and provision this thing ext4. So what we're going to do is we're going to do mk, please, mk fs.ext4, and we're going to point it at our dev mapper, and then vg1 demo, right? Because that's where it actually is. Actually, that's technically a symlink to where it actually is. If you look at our logical volume, or our volume group, which actually, oh, I never did a LV display. Look at that. Okay, so let's do an LV display post setting up. Okay, now you can see that I've got this dev vg1 demo. That's the actual logical volume path, but any logical volumes also get a symlink in this dev mapper thing, so you can use that as well, and I like that because that's where all volumes go, regardless of the volume group. But you can absolutely do it this way too. It's whatever your preference. I don't think there's really an advantage or disadvantage to doing it either way. I think it's going to work for a long time to come in Debian, so it should be fine. Anyway, so now we have an actual file system on this, which means we can actually mount it. So let's do let's do a sudo mount, and then dev mapper vg1 VG1 demo, and then we'll mount it to demo, right? So now that disk is mounted. We can check that with a mount. Type that to grep, and we'll grep for demo, right? And there's our mount. Okay, so we can also do an lsblk, and we can see that we now have this VG1 demo, which is our logical volume, and we can see that it's mounted here. We can see that it's got 1 gig of storage. We can do a df-tac-h, and we can also see here our utilization. We can see that we've got 1% utilized, and we've got an available 907 megs. Not sure where that utilization is coming from. I think it has to do with the labeling, or I'm not really sure. Anyway, that is our deal. Okay, so so now we have our storage. We could totally use it, but 1 gig. I mean, 1 gig is just not very big. We could do better than that, right? We could maybe do 2 gigs at least. So let's go ahead and resize this thing. So you might think to yourself, well, now I've got to unmount it. I got to do all this work. Nope, it's much easier than that. So what we're going to do is we're just going to do an LV resize. So let's do that. Sudo LV resize, right? And now we're going to tac big out. Now here's an interesting little trick, okay? Here you're going to enter the amount of storage you want to grow, either to or by. So if you're in a data center and you're given a spec sheet that says I want this particular server to grow to this amount, so I have a 400 gig hard drive and I want to get 500 gigs, you could say, in our case, let's break it down to our numbers. Let's make it into our case. I have a 1 gig drive and I have a spec sheet that says make this drive 2 gigs. In that case, I would do this, 2G, right? Grow to 2 gigabytes. Dev mapper and then VG1 tac demo, because I know that's the volume I want to grow, right? So now, the other thing that I can do is I can add a tac-r to the end. The tac-r is, it stands for, I guess, resize. And what it does is it's going to run a command in line with our volume group expansion that will resize the file system on the volume as well. Because without the tac-r, what's going to happen is you'll get the volume, the logical volume will get bigger, but the ext4 file system on it will not. So our actual storage that we can manipulate, our provision space, not going to grow. tac-r does all that work for us in line. I'll show you the command to do it if you forget the tac-r after this, but for now we're going to do it this way. Okay, so you can see here that I've resized my volume to 2 gigabytes. So remember, this way is saying I want to resize this logical volume to 2 gigabytes. Okay, let's say I want to grow it. Let's say I get another order that says I want to make my 2 gig volume 3 gigs, but they don't give it to me that way. They say add 2 gigs to the demo volume, or let's say they say add 1 gig to the demo volume, right? Because I'm just going to do this by 1 gig, so why not? In that case, you can do the smart thing, and instead of adding a bunch of, instead of doing math on, because once these numbers get big, you'll have to do math. Let's just do the smart thing and do plus 1 gig. And that is saying increase this volume by 1 gig. So if I did 1G there, instead of the plus, it would try to resize it to 1 gigabyte, which it would probably work because ext4 can be shrank. But it would not do what we had intended, right? We want to grow this volume by 1 gigabyte. We don't want to grow it to 1 gigabyte, right? So what we're going to do is we're going to add the plus sign in, which says grow this volume by 1 gigabyte. Add 1 gig to this volume. Now I'm going to take away this tac-r here. Okay, and now I'm going to do a sudo, and now if I do an lsblk, right, blk, you can see here that the size of this volume is 3, but let's do a df-tac-h, and you'll notice that the size of the volume is really 2. And that's the difference between lsblk. lsblk is showing me the volume storage, what the volume really has. df-tac-h looks at the actual file system. That's the difference, okay? So you can see that I have 3 gigs, but only 2 gigs is really usable. So that's not what we want. What we want is we want to provision all 3 gigs. So what we can do is we can do something called sudo resize 2fs, right? And then we give it our mount or our actual our disk, whatever. So dev mapper, and then vg1 tac demo, and that will resize the volume. And now if I do a df tac h, you'll notice I have 3 gigs available. Ta-da, right? How often do you get to say ta-da, right? So that's that. But what if I got something that says make it the maximum amount of storage there is? I want all of it. All right. Well, let's take a look. Okay. So I want to do sudo lv resize. So that's true. Now I could do math. I could say, well, I know I have 10 gigs, and I know that I've used 3, so really I should just give it a +7 here, right? Or I could just give it a 10, because I know I'm going to 10. You could do that, and sometimes that'll work. But other times what will end up happening is you'll end up with just a little bit of storage off at the back of the volume, and you may end up finding yourself needing to go like 9.997 or some such in order to make it work. Well, rather than do that, you can do tac little l, and you can do 100% free, and then you can do dev mapper vg1 tac demo, and then you can do the tac r trick, right? Now the interesting thing to this is not going to do what you think it's going to do, because it looks like you'll come out of this with 10 gigabytes. You're not going to come out of this with 10 gigabytes. You're going to come out of it with 7, right? And I'll show you that. Now you can see here that if I do a df tac h, I have 6.9 or 7 gigabytes. lsblk, I have 7 gigabytes. Why did it come out with 7? Because 100% free it's substituting a number there, right? So that 100% free is just saying how much is free on the disk, 100% of that. Well, that's 7 gigs, because 7 gigs is what was free, right? So using the logic from our other example, we're resizing to 7 gigs. That's what we've told it to do there. If we wanted to do it to an actual 100% free, we wanted all of the storage to be available to us, we would do a plus 100% free here. This will give us a full 10 gigs. Let's take a look at that. So you can see here now we've got 10 gigs, and if we do an lsblk, we have 10 gigs, and if we do a df tac h, we have 9.9 or 10 gigs. And this is what I'm talking about, where sometimes data will not be exact, like there's a bit or two missing and it makes it round differently, and then all of a sudden you got to do more math than you thought you had to do. So it's important to just keep that in mind when you're resizing these volumes. So at this point we're kind of at the end of the making, creating, and resizing bit. So let's go ahead and dive into a GUI tool that you can check out. It's very interesting, called kvpm. It can be installed with sudo apt install kvpm. Mine is already there, so you're going to get that. And so now you can this tool basically, and let me go ahead and do a refresh on it, because it, you got to make sure it's scanned up to the current point, because this has been open in the background the whole time. But anyway, with this you can view your logical volume. So you can see here I've got my SDB, and you can see it's a physical volume, and it's got a volume group on it. And here you can see my actual volume group. So every volume group will get a new tab at the top. And in here you've got your actual logical volume with your 10 gigs of storage, right? So you can see that. You can provision new disks or new logical volumes or whatever. You can create thin pools. You can do renaming and create snapshots and all kinds of really cool stuff with this tool. It's a really nice tool to lean on, especially while you're learning. But if you're going to be a professional, you're definitely going to want to just learn the command line tools, because those are going to be what you'll be using 95% of the time, as every server you're going to touch will definitely be command line only in almost all cases. I would be pretty shocked if they weren't. It's usually like a security vulnerability if they have a GUI and it's not necessary. So definitely stick with the command line tools, but But if you're interested while you're learning, kvpm will show you some really cool tricks that you can do, like snapshotting and stuff. There are other tricks like, for instance, volume caching that's really neat as well. It's a little beyond the scope of this video, but maybe I'll make a video specifically on that. But basically what it is like if you have a bunch of spinning disks and you want to put a solid state like as a cache volume in front to try to increase performance a bit, sort of like what NVIDIA or is it Intel does with their Optane. I think it's Intel's Optane, I want to say. It's sort of like that. You create a cache volume that sits in front of your physical spinning disk media, and it just adds, you know, performance because you've got solid state caching in front of it. So that's a neat trick that can be done as well. You can Google that if you're really curious, or I'll make a video on it at some point in the future once the main part of this series is done and I'm on to bonus content later. Anyway, so let's move on to removal. How do we clean up after ourselves? How do we destroy these volumes once they're created? Well, we can do that with, actually if we do a sudo and then lv. Here you'll notice that if I hit tab twice, because I'm on ZSH, this might not be the case for you, but you can see in my case, because of ZSH, it will actually display. Actually, I think I'm on bash on this one. This might not even be ZSH. That's funny. I usually use ZSH on my main system. Anyway, if you hit tab twice, it may try to tab complete it for you. And so you'll get all these different options, and you'll see some really cool stuff like rename, which is for renaming your logical volume if you mess up your name, or you know, you can do remove is the one we're actually interested in. Reduce if you want to. I think that removes a disk from the volume, from the logical volume. So if you have a disk that is spanning a logical volume, so if a logical, or should I say, if a logical volume is spanning 2 disks, you can use lv reduce to reduce it to a certain, you know, to get that disk freed up, so you can remove that disk from the group. And then lv resize is, you know, if you want to resize the logical volume, I guess. But the one that I tend to use is extend, create, or remove. Also, there's change here. That's really good if you have like an inactive volume and you want to make it active, or vice versa. LV change is where you would look for that. For the rest of them, you can absolutely hit up a man page and probably, you know, lose yourself in all the documentation on it. But that would be, you know, I could go on for days about this stuff. So I'll get right into how to remove stuff. So let's do a remove. And then we're going to give it a logical volume, or a volume group, I'm sorry. So in our case, it's going to be VG1, and then a / and then demo. And that tells it to remove demo, the logical volume demo in the volume group VG1. So if you press enter, it's going to say it's got a file system in use, and that's because I was stupid and did not unmount it first. So it is currently mounted. So we got to do sudo umount, and then demo, emo, which I can do because I'm still in the / mount. So now if I do that other command, lv remove vg1 demo, it will ask me, do I really want to do it? And if you are sure you really want to, yes is the answer. So now it will delete demo. You can actually give it vg1 as an argument as well, and not the / demo, and it will target all volumes under vg1. So be careful with that, because you may bite off more than you can chew. So, you know, just that's why I say give it the / demo or / whatever your volume name is, because you don't want to delete more than you really bargained for there. But at this point, we don't have that logical volume anymore. So if we do lv sudo lv display, you'll notice that it is definitely gone. So now we can do sudo vg remove to clean up after ourselves on the volume group side. And we can do vg1 because that's the volume group we want to remove. You can see that's now successfully removed. If we do a sudo vg display, we should get no output, and we don't. And then we can do a sudo pv remove dev sdb, and that will delabel our disk as a physical volume for Logical Volume Manager. So basically what that means is now this disk is basically free for us to do different things with now. It's no longer in logical volume. So interestingly though, the ext4 signature was not wiped from the disk, which is why earlier when you saw me reprovision that disk with pv create, it gave me that oh, there's a logical volume, or there's an ext4 file system on here. I think it was pvcreate that did that. One of them did that. Anyway, the reason I got that error was because I had previously did a take on this video and provisioned that, that volume with ext4, and I didn't format or wipe the volume, so that's still there. And in that case, it's going to give you that little error, which is perfectly fine because it's, you know, it gives you the ability to wipe it right there, so it's fine. So anyway, now if I do a sudo pv display, you will see that it does not give me any output, which means my physical volume is now gone and my system is back to its starting point, lsblk. One disk, no volumes. So that basically concludes my little demonstration tutorial on logical volumes. I hope that it has been helpful for you, and I will see you in the next video.